Okay, here's a video on linear inequalities. So let's look at some equations here. We have the top equation is a linear equation, has the equal sign. But when you see these greater than or less than signs, that's an inequality. So you can see signs like this, signs like that, signs like that, and signs like that. Okay, these are the signs that you can see. Okay. In this case here, we're saying that y is less than 3x plus 6. So when we have an equation, let's get a new marker here. So we're saying with a linear equation, we're saying y equals mx plus b. And b is the y-intercept. That's where the line will cross, the y-intercept. And m is the slope. So in this case, we have y is less than 3x plus 6. So 3 is the slope, and it crosses at 6 on a graph. Let's look at this question. So here we have a domain and range box. The x is the domain, and the y is the range. So we can plug in. Here we're saying that y is greater than 5x minus 9. So we can plug in anything. We put in as 0 for x. So 5 times 0 is 0. 0 minus 9 is negative 9. And so forth. We can put a 1 for x. 5 times 1 is 5. And 5 minus 9 is negative 4. And so forth. I'll do one more. So 5 times 2 is 10. And 10 minus 9 is 1. So that's the same way we would do a linear equation. So let's look at an inequality on a graph. The shaded area is the solution. This is the solution right here. Now when you see you could either see a dotted line or a solid line. So when you see a solid line, that means you're either going to see this or this inequality. This means that y could be included on the line. So y could be less than or greater, or y could be greater than, y could be equal or less, or here y could be greater or less. So remember, if it's a solid line, you're using these inequality signs because you can include the solution on the line. But if you see a dotted line, you'll use these inequality signs. Remember that. So let's look at the equation again. So let's try to make this equation. First of all, take any point on the red line and go up. So if you take any point, look, here's a point, and you go up. Here's a point, you're going up. Here's a point, you're going up. If you go up and you're in the shaded area, then this solution is above the line. And just by looking at this graph, you can see the solution is above the line. When the solution is above the line, this is important, when the solution is above the line, you're going to see y is going to be greater, or, depending if it's a dotted line or a dashed line, in this case it's a solid line, so y is going to be greater or equal to, and it's going to be mx plus b. Bring it there. So again, if the solution is above, y is greater. If the solution is below, y is less. One more time. The solution, we went up on the line, and here's the solution, the shaded area. That means y is going to be greater. And it's greater or equal to because it's a solid line. All right, so again, if this was, let's say we had an equation here, and here was the line. Well, let's do it again. Let's say we had a dotted line, and the solution was here, let's say. This is the solution. So if you go up on any point on this dotted line, it's not in the solution, so the solution is below the line. Since the solution is below the line, and since it's a dotted line, y is going to be less than mx plus b. Bring that over. Okay, so again, if it was a solid line and the solution was here, y would be less than or equal to mx plus b. Since it's a dotted line, y is less than only mx plus b. So let's take this again here. From this graph, we can see the solution is above the line. Solution's above the line. Right? So we're saying, and it's a solid line, so y is going to be greater or equal to mx plus b. Now we're trying to find what m is and b. So we can let's look at the graph here. You can see it's right on the 1. So we know what b is already. So here we'll write it up. It's y is greater or equal to mx plus 1 because it's on the 1. Let's look at it again. Right there, it's on the 1. We know that this is going down from left to right, so we know also that m is negative. So now we need to find the slope. So let's look at this graph. You can find the slope a couple of ways. If you go down 2 and over 2, let's see if it happens again. Down 2, over 2, down 2, over 2. It looks like you're going down 2, over 2 each time. So what would that mean? So the rise over run, the rise is the y, over the run, or sometimes you see it as the change of y over the change of x. Right? It's down 2, over 2. So let's circle this for a minute, and then we'll go over it. Let's look at also some points on this line. We have a 0, 1. That's 1 point. We'll put it up here. 0 is x, and y is 1. That's 1 point. And let's look at another point. We have 1, 0. Right? So you can take that. Let's erase this. You can say the change of the rise over the run. The rise over the run. This is how we get the slope. We're saying we can take, and here's the points. We have a 1 and a 0, so we can say 1 minus 0 over 0 minus 1. And you get 1 over negative 1. So the slope is negative 1, which you knew by just doing this before. So now we know our equation. We'll bring it here. Y is greater or less than negative 1x plus 1. In fact, you don't even need the negative 1. You can just say y is greater or equal to negative x plus 1. That's the solution. Okay? Okay, let's look at this. What would this be? So it has a dashed line, right? So let's first find out where is the solution. So if you take a point on this line and go up, it's not in the shaded area. Here's the shaded area. So the shaded area is below the line. Okay? So since it's below the line and it's a dotted line, we know y is going to be less than only. It doesn't include stuff on the line. It's going to be less than mx plus b. Now let's try to get the solution. So where is b? If you see b, it crosses at negative 1 right here. So we know b already. So y is less than mx minus 1. That's where it crosses. Now let's see if we can get the slope. We can do it through the rise over run, slope-intercept formula. Or let's look at the line. From negative 1, if we go up, okay, if we go up 1, 2, 3, 4, 5, 6, 7, when do we reach a solid point? May be hard to see on this. So let's look at the slope-intercept formula. Let's look at some points. Well, we have 0, here's 1 point, 0, negative 1, that's 1 point. Let's look for another point. And here's a point, 2, 5. So we got 2, 5. We have 2 points. Let's bring that up. So we can say 5 minus 1 over, and since we used 5, we got to use 2 for x. 2 minus 0. So it's keep, change, change. So we're going to have plus, plus. This is 6 over 2. And the slope is 3. So we can say now that y is less than 3x minus 1. So let's go back to this graph and see if we can see that. So from negative 1, if we went up 3, 1, 2, 3 over 1, there it is. And we do that all the time. 1, 2, 3 over 1, 1, 2, 3 over 1. So you can see it that way also. So again, that's the answer. So why is y less than? Because it's below the line. And why is it not less than or equal to? Because it's a dotted line. Okay. So just one more time to review. Here we can see the solution is below the line. So y is less than or equal to because it's a dotted line. I mean, it's a straight line. It's a solid line. That's why it's less than or equal to. We're seeing that the intercept is 2, and you can see it right away. It's crossing at the 2. By the way, when you see a system of linear equations where you see two equations, so here are two equations. Here's the dotted line equation. You see this one, and you see that it has a negative slope because it's going down. It's a dotted line, so y is, let's look at this dotted line. If you go up on the line, the solution is here. It's above the line. That's why y is greater. And this one over here was saying y is less than or equal to, because it's a solid line, and the solution is below. The solution is below the line. So right here, where they both meet, is in this dark purple area. So any point in this area would be the solution to the equation. You should rewind that so you understand that. You would graph one at a time, right? And then where they both are is the solution. Here's one where there is no solution. Right? You have y is less than, the solution is below the line. And here y is greater, it's above the line, and they don't meet anywhere. So there's no solution. Okay, so keep that in mind. That's linear inequalities.